Yes, you are having too many. Hey guys, a couple people asked about number 33 and number 34 off the limits, infinite limits packets. So let's just go. Let me just go through and explain those for you. All right. So let's see. So 33 was find the limit as y approaches infinity of y times the sine of 1 over y. Okay, so if I plug this in, all right, I just want to plug it in, I would see that I have infinity times 0 for that one, right? Because this is approaching 0. So infinity times 0, that tells us this does not work. It just doesn't work. It's not like we did talk about examples where if this is exactly 0, then the answer would be 0, right? But we don't. It's approaching 0. So here's what you're going to do for it. You're going to take this and rewrite it like that, okay? Because then this limit that we have here, we can use a let statement, and I'm going to let x equal 1 over y. I'm going to replace that, okay? And then evaluate the limit as x approaches whatever it's going to approach. Well, if y is approaching infinity, then 1 over y is approaching 0. Yep, 0, because it's okay. And it's worth noting that since these are all positive numbers, I'm going to put 0 from the top. Okay, so we're going to add that little plus there. I'm not sure if it matters, but it sometimes does. So that means that this is going to be sine of x, because remember, let x equal 1 over y for x. Okay, so that limit is just 1 right there. So that's how we get 1. In similar fashion, number 34. All right, let me just find that problem real quick. Okay, 34. Find the limit as t approaches infinity of t tangents of 2 over t. Okay, same thing would happen. That right? This is approaching 0, and this is approaching infinity, and that approaches 0. Right? Since they're both approaching, we can't say anything definite about either one. Okay, so I'm gonna, in similar fashion, I'm gonna write this as 2 over t, and I'll write that as 1 over t. I'll put it in the denominator because I'm thinking about trying to apply this property I have for myself. Remember, that was the goal of this unit, just can I apply that property. This right here is the same as the sine of 2t over the cosine of 2t, and I'm just going to banish the cosine of 2t, sorry, 2 over t to the other term. And I mean, remember, because that we can evaluate. Okay, this one's pretty close. Let's use a let statement here. So I'm going to let x equal 2 over t. Okay, and I made it 2 because I need this to go away. So that's going to mean I'm going to find the limit as x approaches infinity. I'm sorry, not x approaches infinity. X approaches 0 again, and it's going to be 0 from above, right? Because these are all positive values. And it's the sine of x. Now remember, this was 1 over t, not 2 over t. So that basically means that if we wanted to be 2 over t, right, I have to multiply by 2 over 2. So that means I'm just going to have 1/2 of x, and 1 over cosine of x over here. Okay. So since x was 2 over t and this was just 1 over t, I just have to basically cut that in half, right, to make that equivalent. Well, this right here is going to evaluate to 1 over 1/2, or 2, when I evaluate my limit, and this is going to evaluate to 1, so my overall limit is 2. Okay.